All right, we're on our third video. This may be the last, or there may be one more. We are on 21. It says find the domain. Well, we know the domain of a linear function is all real numbers. Let's see. That would be this one here. And again, if we were to write all real numbers in interval notation, it would look like that. Now, if you actually graph this, you would start at -7, and you would go up 1, 2, and right 1. That's our slope. The graph would look something like that, and you could see the domain is all real numbers. But remember, for linear equations or functions, the domain is always all real numbers. Similarly, with a quadratic function where 2 is the highest power of x, remember, these are parabolas. In fact, this one looks something like this. And so you can see it goes forever left and forever right. But we know for quadratic functions, the domain is all real numbers. In fact, so far, the only function that we're familiar with where we have a restricted domain is when we have a rational function, a function where there's a fraction. All right, let's move on to 23. I think we're headed for one like that. Not quite yet. So let's look at 23 here first. So this is an absolute value function, and you may recall this one ends up having a V shape, so it's a lot like the parabola, and the domain's all real numbers. You could also plug in some x values, plot some points, and get a graph like this to see that your domain is all real numbers. But again, at this point, all of our functions have a domain of all real numbers, except for our rational functions. And so that would be, our choice here is B, all real numbers. 24. Okay, so 24 and 25 are the ones we're going to look at next. Let's go to 25 first, because it's just a little bit easier. So notice, in this case, remember the domain includes all values of x that we can plug into this function, and our output is a real number. Well, there's one value that we can't plug into this function because it makes us undefined. What can x not be? Well, how about -8? -8 plus 8 would cause your denominator to be 0. 6 divided by 0, you're undefined. So x can't be -8. That's the only value that's going to cause your denominator to be 0. And so our domain is all real numbers except for -8. And notice we have that here. Now, if you had to write that in interval notation, it would look like this. You should be comfortable writing that. Let's go to 24. And in this case, it's a little harder to see what value of x causes your denominator to be 0. And so what you can do is you can set your denominator equal to 0 and solve for x. So I subtracted 3 on both sides. You get -4x equals -3. And then I divided by -4. Notice you get x equals 3/4. And so x equals 3/4, that's the value that x can't be. You could plug that in, and you could see that when you plug in 3/4 here, the denominator is 0. It causes, if you plug in an input of 3/4, you're going to get an answer that's undefined. It's not a real number. And so we have to restrict that, or we have to take that out of the domain. And so it's going to be this one here. By the way, notice 0 is okay. If you plug 0 in, you'll end up with 1/3, because 0 times 4 is just 0. 3 minus 0 is 3. Sometimes students will say 0 here, but that doesn't cause your denominator to be 0. The only problem we have is if our denominator equals 0, and that occurs when x is 3/4. All right, let's move on to number 26. It says, use the graph to find f of 2, f of 3, and f of 4. So when x is 2, that's right here, the height of the graph, notice we're down 1, 2, 3, 4. Let me just move this a little bit. So when x is 2, we're down 4. F of 2 is negative 4. The other way to think of it is this is the point on our graph where x is 2 and the corresponding y value is negative 4. F of 3, well, notice when x is 3, our graph is right on the x-axis. So it's not above or below. F of 3 is 0. And notice the point 3, 0 is on our graph. When your input is 3, your output is 0. And finally, f of 4, we're down 2. So that would be negative 2. And notice that point is the point 4, negative 2. So negative 2 is the value, the output that corresponds to an input of 4. All right, let's move on. All right, on 27, we've got a function f of x equals x squared plus 1, and g of x equals x plus 3. F times g of x, by definition, is equal to f of x times g of x. So that's going to be x squared plus 1, that's f of x, times x plus 3. Notice it's very important that you have parentheses here. When you have a binomial times a binomial, which is what we have, f of x is a binomial and so is g of x, we're going to FOIL this. We're going to multiply our first terms. We'll get x cubed. We'll multiply our outer terms. 3 times x squared is 3x squared. We'll multiply our inner terms. That's going to be 1x, or just x. And our last terms, the 1 times 3, and that's 3. So notice you do have two like terms here. This ends up being x cubed plus 4x plus 3. Let's see, I did something wrong here. Did I mess that up? X squared plus 1. Oh, you know what? This was x squared times 3. This was actually 3x squared. And so in fact, we are done right here. And this is our answer B. All right, let's move on to 28. So similarly, you have two functions, and we're supposed to find g minus f of x. By definition, g minus f of x is equal to g of x minus f of x. Notice the order matters, especially with subtraction. So g of x is x squared minus 4. Notice we're using these two functions, f and g, not the ones we used in 27. And then f of x is negative 5x plus 5. So you got to be careful here, because here this is just a 1. You're going to drop your parentheses for the first set of parentheses. But this minus is going to change both of these signs. You're distributing a negative. So this becomes plus 5x, because a negative times a negative is a positive. And negative 1 times 5, you're going to get minus 5. So again, a minus in front of parentheses will change both the signs for the terms inside. And notice we do have two like terms here. This will end up being x squared plus 5x. Negative 4 and a negative 5 is a minus 9. Notice I wrote the x squared term first, then the x term, and then the constant. This is what we call descending order, and that's normally how we would write these. And that's going to be our answer right here. All right. On number 29, by definition, so again, we have an f of x, we have a g of x, and we're going to get f divide g of x. By definition, that's f of x divide g of x. Well, f of x is x squared minus 3, and g of x is 4 minus x, and that is our answer. Now, I do want to point out one thing here. I didn't have you practice one where you had numbers but you should be able to do the same thing with numbers. For example, up here, let's go back to 27. If you had to find f times g of 2, that would be f of 2 times g of 2. It would be just like doing this one here, except for you would have a 2 as your input. So you'd find f of 2 by plugging 2 into this function. You'd find g of 2 by plugging 2 into this function, and then multiply those two numbers together. So that is something you could see on the test, even though we didn't have one on the review here. All right, let's move on to number 30. It says, find the slope and y-intercept. Well, this is in slope-intercept form, y equals mx plus b, or f of x equals mx plus b. So our slope is negative 10, and the y-intercept is the point 0, negative 9. Remember to write your y-intercepts as points. An x or y-intercept is a point. So we said the slope, oh wait, no, we're done with 30. Let's go on to 31. So here we're supposed to find the slope of this line. So we're going to use the slope formula, and I'm going to call this the first point and this the second point. And I'm just going to plug the numbers in. It's y2 minus y1 over x2 minus x1. That's going to be 10 minus 5 over 8 minus 4, which is going to be 5 over 4, or 5/4. Number 32 says find the slope and the y-intercept of the line. Well, if we found the slope-intercept form, which is y equals mx plus b, we would know both, slope and y-intercept. So let's solve this equation for y. Notice I switched sides. I just put this on the left and this on the right. It doesn't matter what side each of them are on as long as they're equal. So we can just switch sides, and I'm trying to get y by itself, so I'll subtract 24. So we get 3y equals 7x minus 24. Be careful here, you can't combine these together. One's a constant and one's an x term. All you can do is subtract. We have two terms here. Then we'll divide by 3. You get y is equal to 7/3 x minus 8. 24 divided 3 is 8. And so our slope here is 7/3. The y-intercept is 0, negative 8. All right, let's move on to number 33. It's going to be tight here. Let's see. Yeah, we can do this. Okay, so here we're finding a rate of change. We learned that rate of change is basically slope. We want to find the slope of this line. Now, rates are always written with 2 units, like miles per hour, for example. So in this case, we're dealing with the average, let's see, the refund checks. So the average refund check, that's a money amount per year. So we have this change took place over, well, going from 2004 to 2011, the average tax refund was increasing. So the rate of change can be thought of as change in y over change of x. If you look at the slope formula, that's basically what we're finding, because we're subtracting our y values and our x values. So here we're taking these 2 points, and the y values, it's going to be 2,700 minus 2,100. And then so that's the change in the amount of the refund checks. Now, the x values, we're going to subtract 2011 minus 2004. That's basically going to tell us how many years that took place. So basically, if you subtract the numerator, you get $600. And 2011 minus 2004, that's 7 years. So if you divide here, let's see, I got to get my answer key. thought I wrote this down, but I guess I didn't. If you divide 600 by 7 and you round to the nearest cent, you're going to get $85.71 in 1 year, or per year. So basically it's $85.71 per year. That was how much the refunds increased by each year. About that month, or that much over this period of time. All right, let's move on to number 34. Here you're supposed to use the intercepts to graph this linear equation, which is currently in standard form. So to find intercepts, we know we let x be 0. That's how we find the y-intercept. So let's do that first. So I let x be 0. Well, 4 times 0 is 0. 0 plus 2y, you're just going to get 2y equals 8, which means y is 4. So when I choose x to be 0, I get y is 4. So 0, 4 is on the graph. And then we're going to let y be 0. And when I plug in 0 for y, I get 4x plus 0 equals 8, or 4x equals 8, which means x is 2. So we get the point 2, 0, and we can use those 2 points, our special points, we call them intercepts, to draw the graph. Don't forget to put arrows on your lines. They go forever in both directions. Remember, this is a linear equation. This is a picture of all our solutions. There's infinitely many solutions. So our points are basically what represent the solutions. Let's move on to 35. Here it says determine whether the graphs of the two lines are parallel. Well, we're going to want to solve each of these for y, so that's what I did here. Notice I just subtracted 1 on both sides here. I got y equals 6x minus 1. That was this first equation. Over here I solved for y. I subtracted 9x on both sides. Sorry, I just realized you probably couldn't see all that. So we get minus y is equal to negative 9x minus 1. Dividing everything by negative 1, we get y equals 9x plus 1. Notice the slopes are not the same, so these graphs are not parallel. All right, find the linear function whose graph has the given slope and y-intercept. Well, this one's kind of nice because we know the slope and we know the intercept. All we need to do, this is basically our b, is just plug in the numbers. Negative 9/5 x minus 4. Number 37. Find an equation of the line with slope 3 and containing the point negative 4, negative 5. Now remember, if you have to write an equation for a line, oops, let me move this up, or move this just a little bit. If we have to write an equation for a line, we want to use point-slope form. That's this formula here. And so this is my x1, y1. I'm going to substitute here and here. So it'll be y minus negative 5 is equal to our slope, which is 3. That's what they told us here. That's our m. Times x minus x sub 1, which is negative 4. Be careful, in both of these cases, you're subtracting a negative. We get y plus 5 equals 3 times the quantity x plus 4. We're going to distribute on the right. You get y plus 5 equals 3x plus 12. And so finally subtract 5 on both sides. You get y is equal to 3x plus 7. All right, last problem. So here we have to find an equation of the line that contains these 2 points. Notice we're going to have to put it in slope-intercept form. That's the y equals mx plus b form. So the first thing I want to do is keep in mind I need to use the point-slope form since I'm writing an equation of a line. So my slope, I need to find that. I don't have that. I have 2 points, I only need one of those. So to find the slope, we'll call this x1, y1, and this x2, y2. It's going to be y2 minus y1 over x2, which is 0, minus x sub 1, which is negative 9. So it's going to be 1 over 9. So now I can use either of these points. I'm going to go ahead and use the negative 9 comma 0. And I'll talk more about what I did here at the end. So it's y minus, so I'm using m equals 1/9 and negative 9, 0. So it'll be y minus the y value, which is 0 here, equals m, which is 1/9, times x minus our x value, which is negative 9. So this becomes y equals 1/9 times x plus 9, or y equals 1/9 x plus 1. 1/9 times 9, those are reciprocals, and you get 1. And so this is my final answer. Now I just want to point out, I probably should have picked a different problem here, because you actually had the y-intercept here. So once you had the slope, which we said was 1/9, you could have put the 1/9 here and the 1 from the y-intercept right here. I did this way just because on the test you'll have to be able to do it with something where you don't have the y-intercept. All right, so that's going to be it for the review. If you have any questions, just send me an email. Hope that helped.